And we're back.
Yay.
So if you're watching along at home, I am going to go over number 8. Okay. The reason I'm going over number 8, and this is for everybody in the room too, the reason I'm going over number 8 is because I don't like the wording. The wording leads you in the wrong direction. Okay. So let's read the problem together, and then I'm going to change the wording a little bit. A 20-gallon bathtub is draining at a rate of 2.5 gallons per minute, which can be modeled by the linear function y is equal to 2.5 m, where m is the amount of minutes and y, and now this is what I have to change. Y is not the amount of water remaining. Y actually is going to give us the amount of water drained out of the tub, okay? So everybody go ahead and cross that out there, the amount of water drained. The amount of water that has gone out of the tub. The tub is full. We pop the drain. It starts decreasing at a rate of 2.5 gallons per minute. The amount of water drained. All right. Now, let's answer the rest of these questions. Now, this is good that I got this on video because I want to talk through what's going to happen this week. Today, we're doing section 3-4, day 1. Tomorrow, we're doing section 3-4, day 2. And after we do day 2, okay, we're not going to have a new homework over section 3-4 tomorrow, but what's going to be for homework tomorrow? The practice quiz. Okay, practice quiz for homework tomorrow, review Wednesday, quiz Thursday. Okay, we're celebrating Lake Spirit Day with the quiz.
Yay.
Let's go. Okay, so the amount of water drained out of the tub is my output, right? My input is the amount of minutes that's occurring, that's elapsing, right? So, if I wanted to find a function, well, that must mean that I have to figure out what my independent and dependent variables are. Now, on this quiz on Thursday, me and Mr. Delap just made this quiz on Thursday. On that quiz on Thursday, I'm going to be asking you to write out and explain a lot, okay? This is one of like the only quizzes in math class that there's going to be more words on the paper than numbers on the paper. Why? Because I'm going to be asking you, define my independent, define my dependent. Is it a function? Explain. Write out the domain, write out the range. Is it continuous? Is it discrete? When is it increasing? When is it decreasing? So there's not a lot of like computational things, like plug in your calculator type things in this section, in these sections. Okay, so that means it's going to take me a little bit longer to grade. So just, hold your horses on that. Also, that means that you're going to be required to write out a lot and explain your answers. Again, like I said, more words, is not a bad thing. Explain more than you think you need to, and you'll be all right. Okay? All right. There's my soapbox there. Independent variable. What is my independent variable in this case? What is going into the equation? I had a full names. Should I have full names in this class too? No? First period was like, I had to like, yes, thank you for volunteering.
Is the independent variable how much time?
Good. It's time. Oh, that's an N. Let's do this. Time. The number, time, or the amount of minutes, right? If you wrote the amount of minutes, that's fine too. But it's time. All right, so what is my dependent variable? This is what we had to change. This is what we had to shift a little bit. My dependent variable.
How much water is drained?
Good. How much water is drained out of the tub? Amount of water drained. Amount of water drained. That is my dependent variable. I'm plugging in amount of minutes. I'm getting out the amount of water drained out of the tub. So after like 1 minute, there's 2.5 gallons drained out. 2 minutes, there's 5 gallons drained out, and so on. Now, let me ask you, is this a function? Is this a function? Yes. I will be requiring you to tell me why. Okay? On the quiz on Thursday, I will be requiring you to tell me why. You know what the easiest explanation for that is? One input means one output. That's all you have to say. One input means one output. Okay? So we can say it is a function. Now, if you want to state anything else about it, one amount of time only equals one amount of water drained out, that's fine too. Every input equals one output. That's what I need you to say. Every input equals one output. All right, now let's find the domain. Well, I do what I always do for domain, and I think, could it possibly be negative?
No.
No, I can't have a negative amount of time, right? All right. Could I have 0? Yes. And now that, remember, this is kind of what I talked about on Friday. You can, Thursday. You can have a time 0. You can have a starting time. Okay? Now, could I have 1 minute? 2 minutes? Could I have 1.5 minutes? Yes. Could I have 1.1 minutes? Yes. Could I have 1.001 minutes? Yes. Because this is not like, okay, I'm draining the tub and after 1 minute, water disintegrates. You know, like, the whole chunk goes down the drain. No, that doesn't happen like that. This is continuously draining out of the tub, right? The water is continuous, and I'm kind of giving away the next answer, but it's continuously draining out of the tub. It's not like it's happening in chunks. It's happening continuously. Okay, so that means anything above 0 would be a solution, right? So would time 100 minutes be a solution? Is water still draining at 100 minutes?
No.
It depends on how much water. How much water is in the tub? How much water started in the tub? 20 gallons. We have to figure out what time 20 gallons drained out of the tub, because that's my ending point. That's the last member of my domain. Okay? Be careful with this problem. This is why another reason why I wanted to go over this one. Because this one actually has an ending point. I can't say time is going to go on forever because, my outputs are not going to go on forever. I take 20 divided by 2.5, I get 8. 8. So what does that mean? That means at 8 minutes, my graph stops. All the water's out. Okay. At 8 minutes, my graph stops. All of the water's out. So how do I represent that? 0 to 8. Why did I not just say 0, 1, 2, 3, 4, 5, 6, 7, 8? Because it's continuous. And if it's continuous, I have to use an inequality. If it's discrete, that would be that 0, 1, 2, 3, 4, 5, 6, 7, 8 thing. Okay, because this is continuous, and I'm kind of answering the next question. Because this is continuous, I use the inequality. If it's more discrete, that would be the 0, 1, 2, 3, 4, 5, 6, 7. All right, now let's graph the equation. Let's graph the equation. Y is equal to 2.5m. Now, do I need to graph all 8 values? No. All I need to do is see a trend. Because eventually I'm going to fill in my dots and make my line. Okay, easiest number to plug in would be 0. 0 minutes, 0 gallons drained out. Well, let's go by 2's then. 2, 4, 6, 8. Because I know I have to stop at 8. Can I do 9? No. Can I do 10? No. I'm stopping at 8. Because 8, if I plug in 2.5 times 8, I get 20 gallons. The full amount of the tub has been drained. All right. 2 times 2.5 is 5 minutes. Nope, that's wrong. 5 gallons. 4 times 2.5 is 10. 6 times 2.5. I believe that's 15. Yep. All right. So what's the label on my x-axis? What's the word label?
Minutes.
Time or minutes. Yeah, I would accept either one of those. Okay, let's just say time for our purposes here. And now, what's the dependent variable? What goes on my y-axis?
Gallons.
True, but water drained. Water drained. Amount of water drained. Now, the reason I don't want to say gallons is because that might imply like total amount of water still in the tub, and that could be represented by gallons too. So be specific. And again, the reason why we define our independent and dependent variable is because we're defining what goes on the axes. We're defining what goes on the x-axis and what goes on the y-axis. All right. So now let's go ahead and like line up everything. Well, I'm going 0 to 8. I can't go by twos, can I? 1, 2, 3, 4, 5. Just run out. So we got to go by ones. So I'm just going to put marks here. This is, oh, can I go? Okay, black marker. 1, 2, 3, 4, 5, 6, 7, 8. I don't know why I only put those numbers. That's weird. I'm just labeling. Whatever. And now I want to go to 0 to 20. Now I can't go by ones here. Unfortunately, it goes up to like 15 or so. So I got to go by twos. So here's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Again, label your graph. I'll tell you right now, the graph that's on your quiz is this exact image. Okay, I just give you a blank one where you have to fill it in. All right, we go 0, 0. I've got 2, 5, so 2, 4, 5. I've got 4, 10, 4, 10. I've got 6, 15, so 12, 14, 15 right in the middle there, and then 8, 20. Do I fill in my line? Do I connect my dots?
Yes.
Yes. And then there's why, because it's continuous. If it's continuous, then I fill in my dots. Remember, discrete means dots. I'm telling you right now, there's definitely a problem like this on your quiz. And it took us a while to do just now, right? Mm-hmm. There's a lot of steps and a lot of pieces and parts, right? Mm-hmm. So that must mean that there's a lot of points to this problem. So this is the problem worth the most amount of points on your quiz on Thursday. There will definitely be one like that. All right, so let's get to our notes for today. Like I said, we've got 2 more days. Actually, we're going to do a majority of the notes today. We only have like one example to do tomorrow. I probably could have fit it on today's notes, but we just decided not to put it tomorrow. Do one problem tomorrow, and then your homework for tomorrow is going to be the practice quiz. And then we will review on Wednesday, and then we will quiz on Thursday. Now, let me talk a little bit about that quiz on Thursday. That is going to be the first big grade of the night. It's kind of rough having a quiz right off the bat in 9 weeks because that grade sticks for a really long time. Okay? That grade is going to be a majority of your overall grade for a while. That's just the way it is. Okay? I'm telling you that now to make you say, oh, maybe I should study. Maybe I should really do my practice quiz. Maybe I should really put forth some effort to this so that my grade is good right off the bat in the second 9 weeks and I'm not digging myself a hole already. All right. Let's take a look here. Here's my section 3-4 day 1 notes. This is all about function notation. You know how in our first couple sections we were talking more about the application of these things? Like, what is the real, what is the independent variable? What is the dependent variable? What does it mean to be continuous and discrete? And talk more about the not the math side, but like the application side of this stuff, right? graphing word problems and things like that. Today is more about the math side of things, okay? Now, what we're going to be using today, and what this whole section really talks about, is function notation. Now, can somebody tell me again, what is a function? What's a function?
One input, one output.
One input, one output, right? And in section 3.1, we talked about all the different qualifications you had to meet to call it a function, right? Has to pass the vertical line test. We saw that in a mapping diagram, those oval ones, we couldn't have two arrows coming out of it. You know, all sorts of things that if we know it's a function, then it meets all of those requirements. Let me ask you something. You ever walk up to, maybe not. You ever like meet a person that has their doctorate, like an older person that has their doctorate, and they request you to call them by doctor last name, like if it's really formal. Like for example, my cousin, she's a professor at a university. She has her doctorate in English. Yeah, you can get your doctorate in non-medical things. Okay. So she has her doctorate in English. She teaches at a university. A lot of professors at a university are doctors. Now, if you're being very formal about things, okay, could I walk up to that person and call, like if you didn't know that person, if you didn't know my cousin, could you walk up to them and call them Mrs. Laverick? It would be better if you called them Dr. Laverick, isn't it? Wouldn't it be better? Wouldn't it be more formal to call them doctor?
Yeah.
Like, for example, there was an English teacher here. Her name was Dr. Stahl. She was an English teacher. She retired like 6 or 7 years ago. She had her doctorate in English, same type of thing. She taught high school English. She taught AP English. She would ask her students to call her Dr. Stahl, not Mrs. Stahl, Dr. Stahl. Why? Because that's more formal. And guess what? Those people that got their doctorate, they work hard for those two letters. Okay? They go through a lot of schooling, pay a lot of bills. They work really hard for those two letters. So if you're being formal, call them doctor, then their last name. Okay? Why? Because they meet all the qualifications, because they meet all the requirements. And if you're being formal, that's just what you should do. That's proper. The same kind of thing is I can relate that to the same type of thing as function notation. Like, if you say an equation meets all of the requirements to be called a function, if you say an equation passes the vertical line test, every input is an output. If it meets all of the requirements to call something a function, call it a function. Use the proper notation. This is the proper notation for a function. It's like being real proper about it, being real fancy about it. You shouldn't use y equals. If I call something a function, you shouldn't really use y equals. You should use f of x equals. And that's the notation that you see up on the board. F of x equals. That's how we read that. Okay, that function just tells the reader that it meets all of the requirements of a function. Like if you see somewhere that, you know, like it's Dr. Laverick, right? Then you don't even have to question, you know that person meets all of the requirements for a doctor. You're not going to like go through and make sure, right? But if I see this function, f of x is equal to negative 2x plus 5, as the reader, I'm saying, oh, I don't even need to investigate it. I know that it's a function because they're using that notation. Okay? That's the proper piece about this. Now, how is it used? Well, f of x, that f is just a letter that represents the name of the function. Okay? I could use f of x, I could use g of x, I could use h of x, I could use l of x, I could use j of x, I could use all sorts of different letters, and that just tells you the different names of the functions, because there's going to be times when I have different, we're sleeping back there. Come on, wake up. I was talking to you too, but he actually had his head down. You were just sleeping with your head up. Yes.
Am I taking that test today?
You want to take today?
Oh, okay.
Do you want to take during like mentoring? What period? Or do you have study hall?
Mm-mm.
What period is your mentoring? 4. Why don't you come back to me fourth period? We'll do that. So that letter just means the different name of that function. Like, why do we need different names? Well, because there's going to be a little bit later on when we've got 2 graphs, 3 lines, 4 lines, 5 lines maybe on the same graph. And it would be very hard to tell them apart and very hard to talk about it. So what we do is name them different things. Like, okay, look at line f of x, look at line g of x, look at line h of x. Using the same input value, but calling them different things. And I referenced it just right there. That input value, that all that parentheses x means is you're telling the reader, okay, I have this function f, and we're going to input into that function x. The input value is x. So what if I change that? What if I had to say like f of a? What if I changed x to a? Well, the only thing that would do is put an a on this side. Negative 2 times a plus 5. So f of a would be negative 2 times a plus 5. F of c, negative 2 times c plus 5. F of 5, negative 2 times 5 plus 5. 21, f of 21, negative 2 times 21 plus 5. So all I'm doing there is just taking out x and inputting either a different letter or a different number, okay? So let's do that. Let's evaluate those. Evaluate f of x is equal to negative 4x plus 7 when x is 2 and then when x is negative 2. Now, the correct notation to use, if we're being proper, if we're putting our pinky up when we write this thing, because, proper people put their pinky up when they like drink tea or something like that. If I want to find f of 2, now I don't know why I write my f's like that. It's just like a habit that like one of my college professors did, and I thought it was fancy. I thought it was cool, so I started doing it then, and now I just can't stop. But all I'm doing there is just writing a fancy F. I know it's a cursive F. It is a cursive F. So that's, if you see it on my notes, that's how I write it. That's my F of X. It just looks like an F with like a fancy hat on.
Like the letter P.
Bonjour. Right? Just being real fancy about it.
It looks like the letter P just put.
So, if I want to use this function notation, I'm going to say, okay, I want f of, we're doing positive 2. Positive 2.
Bree's going to follow in your footsteps and do the same thing.
The fancy F, right? So f of 2. F of 2 means plug 2 into the equation. All right, if it's negative 4 times x plus 7, it's negative 4 times 2 plus 7.
Is that a negative sign?
Yeah. Okay, so f of 2, and I'm going to write it down below. F of 2 would be negative 4 times 2 is negative 8. Negative 8 plus 7 is negative 1. If we were to go to our calculator, plug negative 4 times 2 plus 7, we get negative 1. That is your whole answer.
What?
Just plug it in. Negative 4 times 2 plus 7.
Okay, that makes more sense. I got really confused how you got negative 1 out of 2.
All I'm doing there is just taking the number that's in the parentheses and plugging it into the equation. The nice thing about function notation is that you can see input to output. You could see independent to dependent. You could see what's going in the equation to what I'm getting out. So let's do that same thing with negative 2. And all I'm asking you to do there is plug in 2, then plug in negative 2. Like on your homework, it asks you to do like 3 different things, 3 different numbers. It's just asking you to do it 3 times. So like here's f of negative 2. Well, f of negative 2 would be negative 4 times negative 2 plus 7. Negative 4 times negative 2 is positive 8. Positive 8 plus 7 is 15. So f of negative 2 is 15. Let's do that again. But now let's make the equation a little bit more complicated. Let's put a squared in it. So if I want to evaluate when x is 4, that's like saying, what is f of 4? Okay, now my new f is 2x squared minus 7. 2 times 4 squared minus 7. Okay, that I'm going to go to my calculator. 2 times 4 squared minus 7. 25. F of 4 is 25. Give me the whole statement as your answer. Show input, output. Same thing for negative 4. If I want to find f of negative 4, it's like two different problems, right? A lot of people are like, what do I do? Do I add? Why the 2x values? I'm just telling you to do two different things. I'm telling you to do two different problems. So this is not now like saying, okay, 2 times negative 4 squared minus 7. So now let's plug that in. Now, use parentheses, folks. If I'm plugging in a negative and I'm squaring it, you must use parentheses. If you don't use parentheses, things are going to go haywire. Look at that. You get 25 again. So f of 4 and f of negative 4 actually end up being the same thing. You might be thinking, well, wait a second. Doesn't that negate it from being a function? No, it can have the same output value, so you just can't have the same input value. Right? You can't have 4 going to two different things. You can't have negative 4 going to two different things. That's what can't happen. All right, so now the next problem is we're going to evaluate, we're going to think about, we're going to logically reason through what these notations actually mean. Okay? So let's start with this problem here. And I say, let f of t be the outside temperature in degrees Fahrenheit, t hours after 6 a.m. So we're waking up 6 a.m. We're going to start our timeline then. And t is the amount of hours past 6 a.m. So whatever goes in that parentheses is the amount of hours past 6 a.m. And whatever it's equal to, the f of t, the f of number, is equal to the temperature at that time. So what does this mean? What does f of 0 equal 58 mean in this context? Well, what is in the parentheses? 0. That means at time 0, at starting time, what's the temperature? 58 degrees. Okay, what is starting time? 6 a.m. So this means at 6 a.m., it's 58 degrees. That's what that really means. At 6 a.m., it's 58 degrees. At time 0, at starting time, it's 58 degrees. Okay? Let's look at the next one. Okay. Now, what is my time? What's my t? 6. Right? So t equals 6. What does that mean in context? What does that mean in our context? When did we start observing the temperature? At 6 a.m. So after 6 hours, what time is it going to be? It's going to be noon, right? So we can say at noon, I hate when it does that. At noon, what's the temperature? 74 degrees. Nice day. All right, so let's take a look at our last one here, the inequality. Okay, what does the t equals 3.5 mean? Yeah. Oh, be careful. This is after 6 a.m.
9:30.
Very good. 9:30. At 9:30. And actually, this is equal to the temperature at 9:30. The temp at 9:30 a.m. Let's put in our math symbol, less than. Actually, do you want to write it in words? We should write it in words. is less than the temperature at, 6 a.m. plus 9 hours, 3 p.m., right? Because that would be like 6 plus 9 is 1,500 hours. So like military time, that'd be 15, which is 3. So the temperature at 9:30 a.m. is less than the temperature at 3 p.m., which makes sense. I mean, that logically makes sense, right? The temperature at 9:30 is usually going to be less than the temperature at 3 p.m. Let's do that same thing. Flip it over to the back. One more of these. The input value is still time. Okay, the input value is still time. But now we're talking about a turkey going in the oven. Turkey going in the oven for 3 hours, 45 minutes. And then it's fully cooked after 3 hours, 45 minutes. Okay, so F of T is now the temperature of the turkey. All right, so what does F of 0 equals 67 mean? Now, am I given a particular time that I'm putting this thing in the oven? No, so we have to use that in our interpretation. So F of 0 just now means starting time. At starting time, what's the temperature of the turkey? 60, cold turkey. The turkey, we don't have to call the turkey, the turkey is 67 degrees. At starting time, the turkey is 67 degrees. Must have let it rest, not from the fridge or the freezer or anything. Okay. What is 3.75 hours? Isn't that 3 hours, 45 minutes?
Yeah.
So if we're going to put it in the oven for 3 hours, 45 minutes, this is when it's fully cooked. At fully cooked. Fully cooked, the temperature of the turkey is what? 165 degrees. That's a number that sticks out in my head. I know cooking temperature for any bird, for any chicken, turkey, whatever, is 165 degrees.
There's like one.
Right, it's like perfect, 165 degrees. I usually cook it way over because I'm nervous. I get scared.
I like to. I would burn it just to be safe.
Honestly, if I'm feeding it to my kids, I always like cooking it. And then my dog goes, Daddy, I don't like the black parts.
Just burn it a little, and you know it's fully cooked.
Right, exactly. All right, so now let's take a look here. F of 3 equals F of 4. F of 3 equals F of 4. So what does the F of 3 mean? Well, F of 3 just means the temperature after 3 hours equals, okay, just turning it into words, equals the temperature after 4 hours. Now, does that really make sense? Well, when am I taking it out of the oven? Oh, so what is the temperature at 4 meaning? 15 minutes after it's been out of the oven.
It's cooling down.
It's cooling down, right? If you looked at a graph of the temperature of the turkey, right, it would be going up, 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 and then 3 hours, 45 minutes, take it out of the oven, that's as hot as it's going to get, and then it's going to start to cool down, right? So the temperature at 45 minutes before you take it out is equivalent to the temperature, I should have moved that line over a little bit, the temperature about 15 minutes after you take it out. So it's going to cool down quicker than it's heating up. Yeah. It's cooking. And then here, 3.75. So the temperature after 3.75 hours, or 3 hours 45 minutes, is greater than the temperature at 4 hours. The temperature after 3.75 hours is greater than the temperature at 4 hours. Which makes sense too. Obviously, it's going to be the hottest it's going to get at that 3.75 hours, at 3 hours 45 minutes. And then I remove it from the oven, then it's going to start to cool. Last problem we got here. Now, this problem looks more difficult than it actually is. And figuring out what to do with it is the hard part. The actual math behind it is not so bad. Like, for example, you find the value of x so that the function has the given value. I'm telling you that the function is 6x plus 9. That's my equation. And I want to find out my input. What input gives me 21? That's what I'm looking for. What is the input that makes the function equal to 21? That makes the y value equal to 21. So all I have to do is solve that equation. Again, that looks a lot more difficult than it actually is. I'm telling you the function is 6x plus 9. I want it to come out to be 21. So tell me the input value that makes that happen. Well, solve that equation. Oh, 2. X equals 2. The input value that makes that happen is 2. Again, all I'm doing there is taking the equation, setting it equal to my output to find what my input's going to be. Got one more of those. So now, do you notice how I'm changing my name of my function? This was f of x, now it's h of x. That's the first time we've changed it. All that means is it's got a different name. Okay? Just a different letter that we use. So h of x is 2/3 x minus 5. And I want to find the value of x when h of x is negative 7. So all I'm really doing is just solving that equation. 2/3 x minus 5 is equal to negative 7. Figure out when that's going to happen. Well, we add the 5 to both sides. 2/3 x is equal to negative 2. I divide by 2/3. So x is equal to negative 2 divided by 2/3, which gets me negative 3. Okay. So your homework for tonight, page 139, 1 to 17 odd. It basically goes through these 3 different examples that I've been giving you. The first example is the ones where I just ask you to plug in values. And let me actually turn to that really quick. Guys, everybody look up here. Take a look at the directions for 1 through 7. It says, evaluate the function when x is negative 2, 0, and 5. All I'm asking you to do is evaluate when it's negative 2. Tell me the answer. 0, tell me the answer. 5, tell me the answer. Do that for 1, 3, 5, and 7. You don't have to do odd. Number 9 is more of those like telling me what it means. Looks like number of customers in a restaurant after tea hours. And then, 11, 13, and 15, and 17, I think. Yeah, those are all, tell me what the value is based on the y value. All right. So long, everybody watching at home.
Goodbye.